as they become aware of the meaning that they attach to it, much like the white rabbit, and then you can take it out and put in the real meaning and the disassociated. But it seems to be, I'm listening to the limbic system and thinking it sounds like the subconscious mind.
I mean, that is perhaps a little bit of simplification, because there are areas like the prefrontal cortex, which is another part of the brain which has a huge role in our kind of awareness of our emotional regulation and our different how we respond to different elements of our experience, and there's another part called there's a whole range of different parts which aren't associated with the limbic system, which also seem to play a role.
But if we're taking it in through the sensory system, and what you find is everybody's unique, so if we've all got the same systems, why is it that people individually we haven't?
But from the slightly scary evidence is that the life experience of our mothers in particular, and possibly our fathers, gets transmitted into the fetus through this process called epigenetics, which I haven't mentioned on the handout, but this is where genes are switched on and off, particularly during the fetus is particularly influenced by this during uterine life. And so we have this fascinating situation where women who were carrying a baby during the 9/11 disaster in America, that the level of their children's cortisol is different to women who are carrying either side of that particular shocking experience. And there's a stronger correlation with the more distress women felt while carrying during that time than those who felt less stress had less of this cortisol condition, of course, of being a stress hormone. So we're different because of the life experience, particularly of our mothers, transmitted through genes being switched on and off and on through epigenetics, and that lasts a generation, a couple of generations. Certainly in lab rats you can show even 3 generations are influenced by these influences. And the more this gets explored, the more crucial it is. You could start saying the kind of the lived experience of that fetus in terms of what genes get turned on and off. And really, I don't think our society is in a state really to cope with the implications of that epigenetics as well.
Could you say that's where like personality traits come from?
Well, you can show that there are intrauterine situations which seem to influence personality traits. If you have twins sharing identical twins, the twin with the bigger placenta, when you trap that twin after delivery, tends to throughout life be more psychologically dominant than the twin that had a smaller placenta, had a smaller blood flow. And so you can show, it's not cut and dry, you can show in terms of proportion that just the blood flow the fetus received, and who knows what was going on in the womb in terms of intrauterine bullying from the bigger, larger fetus, who knows, has an influence after birth. And then as soon as you then are born, you have this flood of data coming into the system through the sensors. Then the brain is so plastic, is so influenced by the experiences it has, that identical twins are diverging, if not from intrauterine life, certainly after born in terms of their experience. So the very fact we use a particular pathway and get that rewarded in that usage will start to change the neurology in terms of that pathway being promoted in the future. If we have inhibition of the pathway, then that will decline. And really, our brains are highly changing up to early teens, and then in the mid-teens to late teens we have this neuronal mega-death as loads of neurons die off, which the pathways that haven't been used that much have phenomenally reduced neuronal numbers. The pathways we have been using continue to develop. And so we have this kind of plasticity up, certainly into late adolescence. And there's some fascinating research recently, well, anecdotal evidence, but very profound, from a woman who had an eye problem as a child, so she didn't have 3D vision. She lost her ability to have 3D vision. And I think she's in her 50s or her 60s, but she did this eye training technique to learn how to point focus with both eyes. And her 3D vision came back. And she said it was a strange experience when a world that was previously flat, all this stuff started looming out at her in a way she never encountered before. And the kind of dogma within neurology is that 3D vision is a window of opportunity to develop that. If you go past that window, that's it, you'll never have 3D vision. And I think maybe she's a unique situation, but so often it's been proven wrong in terms of the assumptions made about how easily the nervous system can actually respond to damage, to how to change. So I think there are genetic elements, there are epigenetic elements, and there are conditioning elements, and how you disentangle exactly what's nature and what's nurture that goes back into intrauterine life, and maybe even previous generations, is I don't think we as yet can easily say. So there are people who are just highly jumpy souls whose adrenal glands will fire off at any slightest shock. There are other people who take a huge amount of stimulus to get the same adrenaline bang for the buck.
But would you then still argue that could be nurture?
Possibly, yeah. So that's and it's likely to be a combination, essentially. But I think the good news is that nurture is very powerful, and so you can retrain the nervous system in ways that, again and again, that surprise the model that people still in the model that was around perhaps 20 years ago, with a fixed brain that doesn't change after maturity. I'll probably just talk through this, and I think we should probably have a break, actually. And just before that, we'll do a short little mindfulness practice. But just to really summarise where we've got so far, hopefully, if we're looking at what's happening in terms of limbic threat appraisal, we have this fast limbic assessment of sensation coming in. The current input is compared to past memories. If a threat is detected, then we use memories of pro-survival behaviours, things that worked in the past, to produce our guess at the best threat avoidance behaviour in that given situation. And if we have survival success, in other words, from the limbic system's point of view it works, then we reinforce that process, and so we get more and more reinforcement of the behaviours that appear to give us success. The cortex, or lumbering thing, slowly responds to the information coming in, and our limbic system, if it decides there is a survival threat, will turn your cortex off, essentially, and say, you're all too slow, we're going to react before you've even made a choice. So if you're stepping out into the road, and a lorry's about to flatten you, and your limbic system identifies that and throws you back, it hasn't waited for you to cause it and go, lorry, could be bad. You better move. It's done the job for you, and it's got you out of the way. But if after the event you think, ooh, thank goodness for that, I'm glad the limbic system did that, or how do you frame it yourself? If your cortex is congruent with what happened, then you get particularly powerful reinforcement. So if you have thrown yourself back, thank God, and you're kind of really happy and glad about the action that's occurred, you even have a sense of cortical success, not just your limbic system, then that further reinforces those types of behaviours. Okay, so one of the reasons why perhaps we can understand that mindfulness practice can be helpful here is it can interrupt some of these fast limbic processes with a different response to the content of our experience. Now, I'll come on to this, it fits in to explain why a little bit later, but I thought it might be nice just to stop and do a little brief practice and then have a cup of tea.